Now we're at example 2 from the 1.2 set of notes. We have this specific function, we have the graph, and we are also included with this table. And we're asked to look at problems A through D and kind of just answer them. So we have f of 0, and if you recall back from algebra, f of 0 is simply taking 0 as an x value, throwing it into the function, and seeing what it spits out. In fact, it's actually the same thing as saying, well, what happens when I plug in 0 for x, what does y come out to be? So if we just look at our graph, we don't have 0 on our table, so that's really not going to help us out too much. But if we look at 0 on our graph, we can see that at the specific x value 0, it comes out with this specific y value of 1. So at f of 0, we should end up with 1. Now when we're looking at the limit as x approaches 0, well, on the left side, I'm approaching 0. And then on the right side, I'm also approaching 0 for our x value. And notice that they end up meeting at the same spot. In this case, 1. So then the limit as x approaches 0, since they ended up meeting at the same spot, just comes out to be 1. It's much like our actual function in terms of our answers. Now, in terms of f of c, f of 1, I should say. Now, when we're looking at problem C, where it's asking, well, what is f of 1? We can even just see that from our graph, we have a hole when we're looking at that specific x value 1. So, as a result, that was where we saw some things that were like undefined. And even from our table, we notice that at the specific x value 1, we have a question mark here. And in fact, if you were to throw this on your calculator, it would, in your table, spit out an error message. So you can go ahead and graph that and just see for yourself. But you should see an error there. And as a result, for the function, when you plug 1 into it, because it's undefined there, because of that hole, this is a DNE, does not exist. Or you could write undefined there if you also wanted. Now, the purpose for this particular example, example 2, is really to kind of connect this idea between C and D. Because for C, we had f of 1 is equal to does not exist, because again, there's that hole there. D, though, is saying, what is the limit as x approaches 1? So in other words, as I approach 1 from the left side, and as I approach 1 from the right side, what are they approaching in terms of the actual y value? Well, it looks to be that they are approaching this value 3. It's not saying that you are this specific x value of 1. It's asking what is it approaching as you approach 1 from the left and the right. You end up with that limit of 3. So the limit as x approaches 1 comes out to be 3. Even from our table, we can see that if you were a little bit underneath 1, your y value is 3. And if you are a little bit more than 1, your y value is 3. So the limit then as x approaches 1 is 3. That's what really differentiates f of 1 and the limit as x approaches 1. Okay? So again, that is example 2 from the 1.2 set of notes.